Welcome to maths classes, students. Today we are going to study the first chapter of NCERT book, Real Numbers. Real Numbers. This is the first chapter of our NCERT books. So first we get introduction of real numbers. Real numbers are any number that can be placed on a number line. Number that can be a number line. Number line, this is a number line. Okay, let this is 0. Here all positive numbers are there and here negative numbers we get. Okay, so real numbers are number that can be placed on a number line. Okay, real number includes rational numbers as well as irrational numbers. Okay, rational numbers are integers, fractions, or on the other way, in other words we can say number that can be expressed as the ratio of two integers. Okay, like if any number can be written as p upon q, where p and q are integers, then we can say that number will be rational number. Okay, integers, and q is not equal to 0. Okay, irrational numbers are the numbers that cannot be expressed as the ratio of two integers, like root 3, root 7, pi, etc. Okay, now in this chapter, in first chapter, we have to learn about the prime factorization of any numbers, and with the help of prime factorization we have to calculate LCM and SCF of any given numbers. Okay, to find out LCM or SCF we need two numbers, HCF and LCM, using prime factorization. Okay, SCF means the full form of this word HCF. H for highest, C for common, and F for factor. And LCM, that is least or least common multiple. Okay, multiple. Okay, what is prime factorization? Before that we must know prime numbers. Prime numbers, we know the numbers having only two factors. That is 1 and the number itself. Okay, what are prime numbers? The numbers having only two factors, that is 1 and the number itself, or the number divisible by only 1 and by itself, then that number is called as prime numbers. Okay, so 1 is neither the composite number nor the prime number, so the smallest prime number is 2. Smallest prime number is 2. After 2, 3, 5, 7, 11, 9 is not a prime number, it is composite. Okay, then 13, 17, 19, 23, etc. Okay, here we can see 2, 3, 5, 7, 11, 13, 17, 19, 23, all are prime numbers because they are divisible by 1 and the number that they are. The numbers which, okay, 2, 3, 5, 7 are the prime numbers. Okay, now we calculate HCF and LCM by using prime factorization. Okay, let us suppose we have two numbers 66 and 420. Okay, and we have to calculate SCF and LCM of 66 and 420. So we write 66 over here, okay, and 420 here, 420. See, the smallest prime number is 2, so we divide 66 by 2, we get 33. Now 33 is not divisible by 2, so we use next prime number, that is 3, and 33 is divisible by 3, and now we get 11 over here. So 11 is divisible by 11 itself only. So we got the prime factors of 66 is 2 into 3 into 11. Now in the same way we divide 420 by 2, we get 2, 2 2s are 4, 2 1s are 2 and 0. Now again we can divide it by 2 because at the unit place 0 is there. So 2 1s are 2, 0 and 2 5s are tens. Now this number is not divisible by 2, so now we move to the next prime number, that is 3. 3 3s are 9 and 3 5s are 15s. Okay, then this 35 is not divisible by 3, so move to next prime number, that is 5. 5 7s are 35 and now 7 1s are 7. So we got the factors of 420 also. Now I'm writing here the prime factors of 66, that is 2 into 3 into 11, and of 420, 2 into 2 into 3 into 5 into 7. Okay, now we have to calculate SCF of 66 and 420. So what is the full form of SCF? Highest common factor. So we have to write common factors only. Here 2 is here, see, we have to write common factors only. Okay, so 2 is here, 2, and here we get 1 2 common. 2 is common over here, so we write 2 one time. Then we can see 3 is here and 3 is in 420 also, so I'm writing 3. Okay, by multiplying we get 6, so HCF we got 6. In the same way, by using prime factorization we can calculate the LCM also. We can find out LCM from these factors also, but we write 66 and 420 together to find out LCM. Okay, both the numbers are divisible by 2, so we divide these numbers. Sorry, this will be 2 2s are 4, 2 1s are 2 and 0. Now see, 33 is not divisible by 2, but 210 is, so we are taking 2 here. Okay, we write 33 as it is, and 2 1s are 2, 2 0 and 2 5s are 10. Okay, now both the numbers are divisible by 3, so 11 and 3 3s are 9 and 3 5s are 15. Okay, now we take 5. 11 is not divisible by 5, so 5 7s are 35. Okay, now 7. Now again 11 is not divisible by 7, so we get 7, sorry, 11. 11 ones are 11s and 1. So here LCM of 66 and 420 equal to 2 into 2 into 3 into 5 into 7 into 11, and by multiplying all these numbers we get 4620. So we get LCM of 66 and 420 equal to 4620. Okay, if we have numbers, then we can calculate the LCM and HCF by using prime factorization, but we have a formula for LCM and SCF equal to A into B. What are A and B? A is first number and B is the second number. Okay, of which we have to calculate LCM and SCF. We are taking an example. If LCM of 66 and 420 is 4620 and numbers are also given, then find HCF of 66 and 420. If we have this number, sorry, If we have the question like this, then we have to use this formula. LCM into HCF equal to A into B. By putting all these values 4620 into SCF, we have to find out A is, let the first number is 66 and the second number is 420. So we are taking this 4 HCF, we have to calculate. So 66 into 420 upon 4620. Now cancel out, this 0 can be cancelled out, and see, this 66 is divisible by 11 and this 462 is also divisible by 11, that is 11 4s are 44 and 11 2s are 22. 42 ones are 41. Okay, so here we get 6. So by using this formula we got our answer easily. So if LCM, SCF or two number, if we have any three values of this formula, we can calculate the fourth one, okay, by using this formula. And this formula is very important, because one question of 2 marks is definitely asked on this formula. So this formula is very important. One more question which is very important, we have to prove that, and one very important question from this chapter is that prove that root 2 is an irrational number. Irrational number. This is the very important question. In our syllabus, root 2 is there, root 3 is there, and root 5 is there. So the process to prove all these numbers as an irrational numbers, the process is same. So root 5, 3 numbers are there, and the process to prove these numbers as an irrational number is the same. So we prove here that root 2 is an irrational number. Okay, to prove root 2 an irrational number, let us assume that root 2 is a rational number. And if it is a rational number, then we know rational numbers are what, that can be expressed as the ratio of two integers. So root 2 must be equal to P upon Q, where P and Q are co-prime numbers and are integers. Co-prime numbers. Okay, co-prime numbers are what? If the HCF of any two numbers is 1, then those numbers are co-prime numbers. Okay, by cross multiplying we get root 2 into Q equal to P. Now squaring on both sides we get root 2 square into Q square equal to P square. Here we can write, we have to write, not can write, it is must to write squaring on both sides. Okay, so squaring this root 2 we get 2 Q square equal to P square. This is some equation number, this is equation number 1, and from here we can say that Q square is equal to P square upon 2. Okay, so from this equation we can say that if P square is divisible by 2, then P will also be divisible by 2. So from this equation we can say that 2 is the factor of P. Okay, now let us assume, okay, and now let P is equal to 2R. Okay, because we had seen that p is divisible by 2, so 2 is the factor of p, one of the factor of p, so we can assume another number, that is r, and it is the multiple of 2. Okay, then p square equal to 2r square. We are squaring both sides again, squaring on both sides. Okay, so we get p square equal to 4r square. Okay, now from equation 1 we are taking the equation from it. Now from equation 1 we can put the value of p square as 2q square, and 4, it is equal to 4r square. Okay, now we are sending this 4 on this side, so we get this equation. Okay, 2 ones are 1 and 2 twos are 4, so from here we get r square is equal to q square upon 2. See, in this equation we can say the, so in this equation we can say that 2 is the factor of q also, so we can write the same line, that if q square is divisible by 2, then q will also be divisible by 2. Okay, so here we got p and q are having same factor. Starting in the start of the question we have assumed that, or we have written that p and q are co-prime numbers, and co-prime numbers are the numbers having HCF 1, but here we are getting the same factor 2, so we can say that p and q are not the co-prime numbers, therefore our assumption was wrong. Therefore we can say our assumption that root 2 is a rational number was wrong. Rational number was wrong, and therefore root 2 is an irrational number. Hence proved. This question is very important, and it is asked for 3 marks. Okay, so students, please revise this question again and try to write down all these steps, because all these points are very important, and do practice for root 3 and root 5 also. Okay, because in a syllabus according to the CBSE 2024 and 2025 is only 3 numbers are there: root 2, root 3 and root 5. So do well practice to prove all these numbers as an irrational numbers. Okay, thank you. And please, if you are new in this channel, then subscribe, share and like my video, and press the bell icon